Fuels and supercharging. Coal is one of the fuel which is a combustible black or brownish-black sedimentary rock, formed as rock strata called coal seams. Coal is mostly carbon with variable amounts of other elements, chiefly hydrogen, sulfur, oxygen, and nitrogen. Coal is a type of fossil fuel, formed when dead plant matter decays into peat, which is converted into coal by the heat and pressure of deep burial over millions of years. Heat conversion of dead vegetation into coal is called coalification. At various times in the geologic past, the Earth had dense forests in low-lying areas. In these wetlands, the process of coalification began when dead plant matter was protected from oxidation, usually by mud or acidic water, and was converted into peat. The resulting peat bogs, which trapped immense amounts of carbon, were eventually deeply buried by sediments. Petrol is a naturally occurring yellowish-black liquid mixture. It consists mainly of hydrocarbons, and is found in geological formations. The term petroleum refers both to naturally occurring unprocessed crude oil, as well as to petroleum products that consist of refined crude oil. Conventional reserves of petroleum are primarily recovered by drilling, which is done after a study of the relevant structural geology, analysis of the sedimentary basin, and characterization of the petroleum reservoir. There are also unconventional reserves such as oil sands and oil shale, which are recovered by other means such as fracking. Petroleum has mostly been recovered by oil drilling. Natural petroleum springs are rare. Drilling is carried out after studies of structural geology, sedimentary basin analysis, and reservoir, mainly in terms of the porosity and permeability of geologic reservoir structures. In some reservoirs, such as in the Middle East, the natural pressure is sufficient over a long time. The natural pressure in most reservoirs, however, eventually dissipates. Then the oil must be extracted using artificial lift means. Over time, these primary methods become less effective and secondary production methods may be used. Supercharging versus turbocharger. Supercharging is a forced induction system that increases an engine's power output by forcing more air into the engine's cylinders, enabling more fuel to be burned and more power to be produced. Superchargers are mechanically driven air compressors that are connected directly to the engine's crankshaft or other rotating parts. Forced induction, the supercharger compresses the air before it enters the engine, increasing the density of the air-fuel mixture. Increased power, this increased density allows the engine to burn more fuel, resulting in a higher power output. The first supercharged engine was built in 1878 with usage in aircraft engines beginning in the 1910s and usage in car engines beginning in the 1920s. In piston engines used by aircraft, supercharging was often used to compensate for the lower air density at high altitudes. Supercharging is less commonly used in the 21st century. Turbocharged engines use energy from the exhaust gas that would normally be wasted, compared with a supercharger which mechanically draws power from the engine. Therefore, turbocharged engines usually produce more power and better fuel economy than supercharged engines. However, turbochargers can suffer from turbo lag, especially at lower RPM, where the exhaust gas flow is initially insufficient to spin the turbocharger and achieve the desired boost level, thus leading to a delay in the throttle response. This is often a result of a turbocharge which is too large for the engine displacement. For this reason, supercharged engines are common in applications where throttle response is a key concern, such as drag racing and tractor pulling competitions. A disadvantage of supercharging is that the engine must withstand the net power output of the engine plus the power to drive the supercharger. Additionally, turbochargers provide sound dampening properties to a car's exhaust note, while a supercharged engine maintains the louder exhaust note of a normally aspirated car. However, supercharged vehicles maintain simpler exhaust systems as turbos require extra exhaust piping to function, whereas a supercharger typically bolts directly onto the intake manifold. Turbocharged engines are more prone to heat soak of the intake air, since turbocharging can place the hot exhaust components near the intake air system, although this can be overcome through the use of an intercooler. In an internal combustion engine, a turbocharger, also known as a turbo or a turbo supercharger, is a forced induction device that is powered by the flow of exhaust gases. It uses this energy to compress the intake air, forcing more air into the engine in order to produce more power for a given displacement. Turbochargers are distinguished from superchargers in that a turbocharger is powered by the kinetic energy of the exhaust gases, whereas a supercharger is mechanically powered. Like other forced induction devices, a compressor in the turbocharger pressures the intake air before it enters the inlet manifold. In the case of a turbocharger, the compressor is powered by the kinetic energy of the engine's exhaust gases, which is extracted by the turbocharger's turbine. The turbine uses a series of blades to convert kinetic energy from the flow of exhaust gases to mechanical energy of a rotating shaft. Some engines use multiple turbochargers, usually to reduce turbo lag, increase the range of RPM where boost is produced, or simplify the layout of the intake/exhaust system. The most common arrangement is twin turbochargers. However, triple turbo or quad turbo arrangements have been occasionally used in production car. Turbocharger failures and resultant high exhaust temperatures are among the causes of car fires. Failure of the seals will cause oil to leak into the exhaust system, causing blue-gray smoke or a runaway diesel. The key difference between a turbocharger and a supercharger is that a supercharger is mechanically driven by the engine, often through a belt connected to the crankshaft, whereas a turbocharger is powered by the kinetic energy of the engine's exhaust gas. A turbocharger does not place a direct mechanical load on the engine, although turbochargers place exhaust back pressure on engines, increasing pumping losses. While a supercharger is always spinning and putting in more fuel and air, if a turbocharger only works above a certain engine speed, it's possible to cruise with the efficiency of a smaller engine and then have the performance of a more powerful one when desired. Some benefits of turbochargers are improved high-altitude performance. Turbochargers can compensate for the reduced air density at high altitudes, helping to maintain engine performance. Quieter and more refined engine noise. Turbocharged engines can be quieter and smoother than their naturally aspirated counterparts, offering a more refined driving experience. Environmentally friendly. By improving fuel efficiency and reducing emissions, turbochargers contribute to a more sustainable transportation system.